let's get cracking. So, good morning. Welcome to this event hosted by the Future Urban Ventilation Network, one of a series of events which we've been doing over the last few years. My name is Tim Sharp. I'm a professor at Strathclyde University, head of the Department of Architecture, and I'm your host for this morning. We have two for the price of one today. So we have Alejandro Moreno, who is a lecturer here at Strathclyde, a colleague of mine, and also Kirsty Maguire, who's an architect and Passivhaus designer, and they have been collaborating together on this project, looking at a Passivhaus development. So, Alejandro, I think you're going to share your screen and kick off. Is that right? Do you want to get your screen up?
Let me just.
So if you have questions, either put them in the chat or save them to the end, if that's okay, and then we'll kind of go around them when we get to the end, if that's all right. I think you'll have seen we're recording this. It's just so we've got a record of the presentation, and I'm assuming everybody's okay with that. So Alejandro, over to you. I'll let you kick off.
Yeah, thank you very much, Tim. Well, as Tim mentioned, I am a lecturer in Strathclyde. I've been working in this project with Kirsty since October, November last year. It's been quite interesting. Kirsty, I don't know if you want to introduce yourself a little bit more.
Yeah, thanks. So I'm an architect and Passivhaus designer. I've been working in Passivhaus since about 2007 and set up the practice in 2011, and all our work is based on Passivhaus. So we work across Scotland and worldwide, from the Southern Ocean to the Arctic, which is fantastic challenges. Very interesting looking at how weather and climate impacts this. We've got two colleagues who are just joining in as well. And the work that we do practice work. So we build buildings. We also do specialist consultancy. We do some research, for example, this. And we also do a lot of Passivhaus training for a whole range of different people, contractors, other consultants, etc., local authorities. So nice and varied. I do have one request. If you would like to, if you're not shy of turning on your camera, because it means that we're talking to real humans. But yeah, it is optional. Thanks.
Yep. Well, I've been working as well as a lecturer in net zero and building performance evaluation for the last couple of years with Tim. And I think that this project sort of builds up on that in terms of what is the path in Scotland for net zero. I think Kirsty was going to mention a couple of brief things about this. Is it this one? Well, okay, so this one is just looking at what the typical net zero building might look like. So we have here what a Passivhaus and Enerfit, which is the retrofit part of the Passivhaus, and how does it compares to the rest of the UK in terms of space heating. And as we move to net zero, we need to try to reduce this a little bit. And this is the part where Kirsty was coming over here. Sorry.
Thanks. Yeah, so you may or may not be aware that the Scottish Passivhaus equivalent is currently being determined for the new building regulations that are coming in at the end of this year. So what that looks like, we don't yet know, but that was voted in through the Citizens' Assembly with 97% of approval, and it's got cross-party support. So really keen that this continues on. So this is in part being developed with a number of stakeholders as part of this process, including the Passivhaus Trust. So that what that looks like and how it's going to be implemented is still under discussion, but very soon in the summer there'll be consultation, which we encourage you to have a look at. And then the intention is that there's a period of time for that to embed, where you can also use Passivhaus as a deemed to satisfy in the building regulations. So that's the proposal at the moment. What that comes out in the wash over the next 6 months remains to be seen, and we're really excited about it. So do you want to go to the next one? So, but there are challenges. So upskilling is a key part of it, and some of the one of the big challenges actually is ventilation, which of course has a big impact on indoor air quality. We'll be talking about how that looks on some of our projects throughout it, and also general industry upskilling. But I think the main discussion here is that none of this is rocket science, and what I like to think about it is it's evolution, not revolution. So any good contractor can undertake this work, and it is happening at scale in schools already, and it's been wholeheartedly embraced. So there's no particular reason why this shouldn't happen at scale over the next few years in housing as well. So we're really excited about it. That's it.
Sorry, you were going to add something else? So we have been talking about Passivhaus, but I just realized that we haven't actually told you guys what a Passivhaus is. For some of those of you that don't know what the Passivhaus is, it's probably a very energy efficient house, which relies in building systems such as MVHR, mechanical ventilation with heat recovery, to provide ventilation, but also to provide good indoor air quality. And it has also other features such as the windows and doors, which are tightness and good thermal insulation and thermal bridge. And something that is becoming more and more common in this kind of houses is as well problems with overheating. We have major overheating problems in Scotland over the last year. So shading and solar gains are getting part now of what we need to start looking at Passivhaus homes. I'm just going to be going very briefly on this because I would expect some of you already know a lot of Passivhaus, probably more than me. But Kirsty has been working on this project, and she's going to introduce what the project is, and then I'll be looking a little bit in terms of that indoor air quality impact on the project.
So it's a new built house, and as Alejandro just said, so Passivhaus is very much about a fabric first approach. So we're really focusing on getting the quality of the construction right. And why do we do this? It's about low energy in use and high comfort. So the comfort and health element of it is something that is slightly harder to make tangible, but I think that's where people like yourselves come in significantly with the indoor air quality review and development. And I think the other key thing is this stress testing in the modelling on buildings. So we're looking at potentially future climate change. So the sort of standard uplift that we look at as part of certification is 2 degrees, and as part of our everyday modelling. This house, this was completed in about 2.5 years ago. It's on a north-facing site, just outside Dundee. So we're looking over the Tay here towards the city. And often people come and say, we don't have the perfect house for Passivhaus, so we can't do it. The perfect site for Passivhaus, so we can't do it. This one, it's north facing, the views are to the north, it's semi-built into the hill, so you've got very little south solar gain, and east and west views are very limited because of privacy with the neighbours. So you definitely don't need to have a perfect site to achieve this. Next. So there's 2 ways to certify Passivhaus. One is with heating demand, which is the 20 number there in this particular one. So these are the results for this house. And the maximum you can have if you're certifying for that is 15 kilowatt hours per meter square per annum. And the heat load maximum is 10 watts, but you don't have to achieve both. You can achieve one or the other. So in this case, you can see that we're meeting the 10 watts per meter squared heat load. So that's a peak heat load on the coldest types of day of the year. And what we're looking at, because initially we're focusing on fabric, we're looking at the losses and the gains. Now you're optimizing solar gain. So another sort of misconception is often that you're maximizing solar gain, and that's part of the issue with overheating, be that in Passivhaus or any other type of building. And of course, what we're looking at is balancing the losses. Let's just go back for 1 second. Yeah. So the infiltration on the losses graph, hidden in there, something from the top, you can see that's pretty small amount, and that's because the building is not completely sealed. You've got a small amount of, your air tightness is not 0. You've still got a small amount of infiltration, but what we want to do is to minimize that. And so we're intentionally ventilating, and you're intentionally ventilating with the mechanical heat recovery ventilation system which runs all the time. But you can also open the windows. And of course, during summer, you probably be doing that anyway. You might want to do that at night for night purging if your building's, if you want it a bit cooler at night. But also you get fresh air during winter, which in most, particularly housing is what we're talking about just now, but of course most people don't want to open the windows to ventilate in winter because it also lets the heat out. Next.
Oh, sorry.
So this is a fairly typical type of construction, although the type of timber frame varies in Scotland for this sort of scale. Timber frame, super insulated, and then whatever kind of cladding you want. It's very standard, but really the devil is in the detail. We'll look at that in a few of the examples later on. But that sketch elevation at the bottom, that is all of the south-facing glazing in this building, and the rest of the building is semi-buried. So not an optimum site, but certainly possible. And this is the north-facing side. And in fact, the small building at the front it's very small. It's only 38 square meters, so it doesn't meet Passivhaus, full Passivhaus. It meets, but it's all built to the same details, and we also have ventilation in here. And in fact, it's covered by the monitoring that Alejandro is doing as well, but separate to what we're talking about today. But the house there, you can see massive north-facing windows. So technically, you've got relatively large amount of heat loss there. But the key is because we're using high performance components, you're not getting downdrafts, you're not getting cold spots, and you're avoiding issues with condensation, which has, of course, further elements to consider in terms of risk of mold, health of the building, health of the occupants, and so on and so forth. And that humidity element, Alejandro is going to talk about a bit more as well. So that's the building.
So what we have been doing is we decided to do a little bit of monitoring in this house, and it has been ongoing since the 24th of October. And the data that we're going to see today is up to 31st of May. We are looking at temperature, relative humidity, and CO2. And as well, we did a little bit of monitoring, of energy monitoring through energy by circuits, although I'm not going to go into a lot of detail of that today. But probably the only thing I'm going to mention about energy is, well, already Kirsty mentioned that the house metered the 10 kilowatts hour. The house has actually got a demand lower than the 20 that she has got on the certification bit, at 14, I think it was.
So the certification is 20 and 10, so 10 for the peak load and 20 for the heat load. Looking very roughly speaking on the first year of monitoring, which wasn't nearly as detailed as what Alejandro is doing now, it was coming in at about 14 in reality for space heating. And that we'll see in a moment partly why that is, but in terms of really running it. So it's all modeled at 20 degrees, but the average over the year is a bit lower. That's just a personal preference of the people who are in it, but Alejandro will talk about that a bit more as well.
So what we can look here is a little bit of those temperature trends that we see in the indoor of the house, and here on the bottom we see what is the outdoor trends of the temperature. And it looks like, as a first glance, that is quite stable through all the day. As you can see, most of the time those temperatures stay over. This is the temperatures on the first floor, and these ones are on the ground floor and first floor. And one of the things as well that is quite interesting here to notice is that while we would look over at temperatures between 20 and 25 as a part of the Passivhaus certification, but as well as sort of the established normal comfort ranges. Not because the house has been modeled to that, you need to live into that. Sometimes the occupant has other preferences, and in this case, as well, that's quite notable. And the other picture that we have here is as well that when we look at the same data, but including the max and mins, through all the data, we see that that still remains very, very stable through all the time that we have been looking at. And again, it's just looking at those difference between what is the ground floor and the fifth floor. And something quite interesting that Kirsty mentioned as well is just looking at that overheating. We don't have a lot of overheating in this house, but in some problems or sometimes that could lead to excessive off-gassing from other products. We're going to talk a little bit of that detail later on. And just as a very fast way of finalizing with the temperature, as you can see, the temperatures are very, very stable through all the time. We can sort of look at that most of the time they were as well only that 20 degrees that we were expecting it to be, and very little above, and certainly not much above the 25. However, this data is only showing winter and what we have been going through the summers, through spring, so summer data might change this a little bit at a later stage. Relative humidity is a very similar story, although here we're looking at trying to probably reduce the humidity from outdoors. And we have here the humidity in the house. What the yellow line is the utility room, so that is expected to be in those levels. And once we remove that line, we can just look over as well at those fragments of the relative humidity, and most of the time remains between the 40 and 60, which are seen to be the key points. Below 40 is considered to be dry and starts causing a lot of problems on the skin and as well for the occupants. And above 60 is considered to be leading to problems of condensation and mold and so on. Of course, there is a little bit more of theoretical background to go there, but that's usually what the ranges we need to try to keep up here. And the house does meet that. And there is a lot of literature and a lot of perception from people looking at relative humidity, where they believe that the passive house tends to have very dry temperature, and they start keeping water balls over the radiators and that kind of stuff just to increase the humidity. But if it's well achieved with enough detail, we don't have this problem that much. So here we see a little bit of that percentage of time on the houses, on the house that we have here, on the different rooms. Most of the time was within what we would expect on those time frames, but as well just here looking at that high peak on relative humidity on the utility room. And that's probably as well where we're extracting the air in any case through the MVHR system in the passive house. So that helps as well to keep going. In terms of what CO2 levels we have in the house, this is probably very standard what a passive house would look like. Those CO2 levels are sort of like a cardiogram of the house, where you can see all those peaks and goings ups and downs. And that's probably when there is people coming into the house or a lot of differences. But they tend to remain very stable, as we can see here. And this 400 ppm of CO2 is mostly what we would expect outside. So it's quite interesting to see that the house is usually within that range of 400 to 600. And even if we start looking as well in terms of what are those higher peaks, we see that the house goes to looking into those higher peaks, but it actually doesn't go for longer periods of time above those peaks. And it's usually when we have things like sleeping at night. Here, there is something that happened. There was an event in the house and there were 60 persons in the house. And the MVHR system remained on the same standard characteristics. It went up to 5,000 that night, but as you can see later on, just remained over what you would expect. This is also something quite interesting because, as Kirsty was mentioning, a lot of the perception, well, You can open the windows in the passive house as well as you would do in any other house. And other point as well is that you remain as well with constant ventilation through all the time, even during winter when, for example, in a normal house, a standard home, you might not be able to do it. You would need to open the windows, and that probably mean cooling the house very, very fast. And here in a passive house, you don't get that. So you still remain in those constant ventilation through all the time. We see a little bit here as well in terms of how the CO2 remain on average through all the time, mostly within below those 100 ppm that we would expect. And of course, this was a little bit of the peak here looking at that living room, and usually on the bedroom one is where we have 2 persons there at the house, which is a normal thing to do at night, more ventilation there. So a little bit of what the challenges I'm trying to achieve the passive house. I'm going to pass it here to Kirsty, and what that means as well for air quality. I'll be going into detail later on in that.
Thanks. Next. So we've got a few other projects just to run through a few different elements of challenges that we look at and how that impacts what we do and obviously relating to indoor air quality. This is one of the very first passive house buildings in Scotland. It's one of ours, and it was based on in terms of design, it was based on a hay shed of pretty much the same colour and shape as this. Next. And what you'll see on any of the drawings is a red line, and that continuous red line is the air tightness layer. And the key for this intentional ventilation is that that air tightness layer is continuous, it's well detailed, and it's well installed. So what we're looking for is a maximum of 0.5 air changes per hour at 50 pascals, both pressurized and depressurized, so that we're not getting drafts, which of course leads to discomfort and heat loss. But one of the other things we're looking at is thermal bridges and making sure that we're not leaking heat in the same way that you might leak air. And in this sort of evolution, not revolution process, you still sometimes occasionally find people who are keen to do strip foundations. But I think this is the kind of thing that contractors will only do once, because it's by the time you insulate anything that involves wall ties, that's a good time to stop doing it and design something different. There's always a discussion, and what's really important in all of these is the collaborative process between contractor and architect as well, and the rest of the design team for that matter. Next. So what we do though, and this is a typical strip foundation but insulated, but here what we're looking at is 2 versions, and on the right those are thermal models looking at the heat loss, and that's really only the change between a lightweight block and a standard block really significantly increases heat loss. But what's relevant also about that is the internal surface temperature becomes a lot cooler, so that's where you get condensation and mold and all the associated indoor air quality risks of having that in the building as well. Next. So for the upshot of this now is that we design all of these out, and at that point there were very few products available in the market, and the contractor, they were ready to take on most things, but that thing was a step too far for them. However, having done this, they realised that actually they should have gone that way as well. So now typically we'd use a raft foundation. We've got an image of that further on. But in terms of air tightness, that needs to be thought about even as the structure is going up. It's not something that can just happen later on. And it has to, the design and the testing of that needs to be thought about right from day one in the sketch designs, particularly on larger projects where you've got multi-unit housing or larger projects such as schools, because there's the practicalities of testing as well, because it is possible to do an entire large building, but often because of sequencing in the construction process, it's far preferable for contractors that you're doing the buildings bit by bit. Next. So this one here, the other thing in terms of design that we need to think about is how complex the building is, because regardless of whether it's Passivhaus or not, complexity equals cost, and every client has a budget. And what we want to be doing is spending the budget on good quality design, but also good quality execution of that design. So the actual construction. So this is a project in Dundee. Next. And in plan, it couldn't be much simpler. It is a box, and that red line is your airtightness line. Next. But in section, you can see where we've created, if you like, the architecture with capital A and associated complexity is in the roof line. And that creates, even though upstairs is mostly an open plan space, that starts to create volume. So we're thinking volumetrically about the space. But then you know, it's all about the devil again is in the detail here. And also at the bottom of this building, you can see what we call a raft foundation. So it's a concrete slab, just in essentially a tray of insulation. Much quicker to build, much simpler. Actual insulation is a bit more expensive, but the construction process is much faster. So that cost is recouped by the contractors. So contractors are doing that like for like cost to traditional foundations, even though there's a perceived risk in some of these things. Once they've done it once, they love it and want to change. Next. This is just what the building looks like. It's an element of a Marmite building, as I call it. Some people love the design, some people don't. Next. But inside, it's an upside down house. And in terms of summer cooling, what we're looking at is a lot of stack ventilation. So that's the other advantage of these slightly taller spaces. Roof lights, like you can see in that picture on the left. So nighttime purge cooling on days like we've had over the last week or so allows that to remain at a good temperature. And in terms of, again, look at the red line for the airtightness. The whole thermal element of this is a discussion perhaps for a whole other day. But what we're doing here is minimizing the risk of thermal bridge for continuous insulation, but also making that airtightness line really simple to build, or as simple as it possibly can be. And the other key thing is using appropriate materials. So there's a QA process on site that needs to be managed by a contractor, to make sure the sequencing is right, but also make sure that all the people on site understand the importance of not damaging that airtightness layer. So that is something that's new, and that's part of the upskilling. And this is a raft foundation, the sort of tray that we mentioned. So it makes all of this a lot more simple to achieve. And these kind of products now, you've got a choice in the market. And we've also got, these are easily available. Next. And again, thinking about mid-floor detail. So sometimes you don't need to make that much of a change to a detail to make it work. And sometimes actually it's easier and quicker and less costly to make a bit of a jump. And in this case, there are lots of ways to do a mid-floor. But here, what we're looking at is actually a balloon frame and putting in that airtightness layer before you put the mid-floor in. So again, sequencing is really important, highlighting that kind of thing to the contractor. Next. So this is another house. This is up near Forest. And the client asked for a traditional farmhouse. Then we talked through what they were looking for, and we developed something that was still inspired by a traditional farmhouse, but slightly more contemporary, open plan, light and bright design, but also designed for extension because they're a young family. The idea that they could easily add bedrooms, we could on the other side of the building, all the windows are where you put doors. Those windows can be taken out, you can reuse them, and you don't have to make structural changes to the existing building to do that kind of extension. So we think a lot about some of these other elements of long-term sustainability as well when we're working. So next. But how do we test this? And again, this was a little while ago, so products, and this comes down to product claims, and this is, the market is rapidly changing, and as designers and contractors and people who are checking and researching these buildings, I think it's really important to understand that the claims that suppliers are making are not always substantiated or tested yet. So these particular windows, was, on paper, they were fantastic. In reality, not so good, unfortunately. So what happened here was that, as you can see on the bottom right, some of the seals failed. And so some of the benefits of that airtightness and intentional ventilation were lost. And in that case, of course, it may be as much as replacing the unit. Again, this kind of, I'm sure you're all familiar with thermal imaging, but it's super helpful for us, both in terms of assessing the building, but also actually good contractors that we've worked with have really embraced thermal imaging as part of their own internal checking. So they're checking the work that the guys have done so they can go and make sure that actually what they're building is what we're expecting, what the client's expecting. So the good contractors are using these tools as well, rather than having it foisted upon them, which I think is really interesting. Next. This particular building was managed on site by the client. Clients who are very capable of doing that. But one of the things that they chose to do was to reduce the specification of the ventilation system. And I think as we upscale in Scotland, in the housing market, then ventilation is a big area where there just aren't enough people who are working in this zone in the construction industry at the moment. And this was a typical example of where that was down-spec'd a bit. The supplier commissioned it, but not very well. And so actually, when we did this basic monitoring, this is an ATAPMO system, then we found that the CO2, which is the bottom here, was higher than I was expecting, and it was fluctuating much more. And what was interesting was, because the clients had come from an old building, like an old farmhouse, as far as they were concerned, the indoor air quality was absolutely amazing in comparison to what they'd ever experienced before in any other building. But looking at this, we went, hang on, it's still not as good as it should be. So they subsequently went, it was recommissioned, and this improved. But I think it shows very much partly the value of the monitoring and evaluation, but also as we're upskilling, that's one of the big challenges that we're going to have, particularly in this area. And this is, of all the different things in this upskilling and changing the regulations, this is one of the things that's been identified as something that will be key to address through the transition period to Passivhaus equivalent, whatever that looks like. Next. So again, a different house, and this one is in Perth and Kinross. Different style. Next. Then airtightness testing. So there's various different ways to airtightness test. I haven't read the comment in the chat, but I imagine we may end up discussing different airtightness testing later on. But typically what you do is bring along a blower door test, testing kit, and pressurize the house. And for Passivhaus, you need to depressurize it to find all the leaks. And this is, you can't have everybody on site, because of course you can't open doors as you're going around. It needs to be sealed for the duration of the test. But it's really fantastic to have the key people from the contractor team there, and many of the people who are actually the joiners, Nicholas at timber frame, because it's the only really visual element that they have of why this quality is so important. So we've had people at the start of the test, they're like, oh, well, I like to do a good job, but I'm not really fussed about all those tiny little bits of taping or making sure it's spot on. By the end of, an hour or two later, they're completely like, oh, wow, we're really into this. We really enjoy having this, I guess, validation of their skills. So they can do a good job and it's immediately recognised. And we've had quite a lot of feedback from contractors that actually building to this level of quality gives them a real joy in their work. So actually, the interesting element of that, it also comes down to like mental health and job satisfaction. People are building it as well as there as well, who get the building at the end. So there's all these sort of elements to good quality building, in this case Passivhaus, that are things that we didn't really expect to come out of it, but in this case through discussion with contractors as well as the end users of the building, you get this bigger picture. Next. Imagine many of you have seen an air tightness test in progress, but just in case not. So this is, you don't always have to use smoke like this, but it's very useful for in-depth testing. So in this case, we're putting smoke against any area that we think are high risk of having gaps in the building, and the building is depressurized. So what we would see is smoke coming through if there was an issue. And in the next slide, we will see, so this one worked really well. In the next part, there's two elements here. One, they'd run out of time, they'd run out of materials, and so there was a lot of smoke coming through the building fabric and into the room. Also, we discovered that there were some weak holes in the roof light that was there, which was a Passivhaus specified roof light, which actually was, that's what you see there with the smoke coming through. So, and the reason for that was because, you know, it's very unlikely in triple or quadruple glazing that you're going to have condensation on the inner face. You're much more likely to have it on the outer face. But that was almost a hangover from the design of the double glazed units in terms of design and iterations of design of a product. So that may have been changed now, I'm not sure. It was, again, it's really interesting looking at how these products are impacted. And in fact, on another project, we discovered there was an issue with seal when we were testing the building, and the window seals all failed. And what we fed that back to the contract, further to the supplier, who were very good. I have to say they're super about their response, and they said that they just changed the way that the window panes were put in the factory, and through this they realized that there was a potential risk point where some of the windows were fine, or most of the windows were fine, but some of them were not fine, and we had a bad batch of windows. But what they did as a result of that, well, partly they came and fixed all the windows without any issues whatsoever. Also, they changed their system in the factory. So it's fantastic to have that relationship with suppliers, and sort of responsiveness to development of products as well, just through testing something which actually we were testing for something totally different, which was air tightness overall. So next. So one of the other things that we're looking at is embodied carbon. So Passivhaus doesn't talk about what materials you use in a building. But of course, as part of our overall ethos as designers, we are thinking that, and we're looking at low energy buildings and low energy materials. So this is from the spiky house that you saw, and this all meets Rebird 2030 challenge targets, etc. But what it showed actually was the biggest contributors individually to elements of the embodied carbon were the services. So there's PV panels, also mechanical ventilation in here as well. So the overall of the lifespan, it's great to have that, and in terms of indoor air quality and avoiding heat loss, it's absolutely necessary. But I think what's really key is that as designers, we're optimizing that. So in terms of ventilation design, we're minimizing the extent of the kit that we need, or any other of these bits of kit that we need, through good design generally. Next. And we also look at a whole range of other things. So recycled materials, reclaimed, avoiding cement in one particular project, which we finished recently. If anyone's interested in finding more about this project had loads going on in it, and quite a lot of research work done along the way. It's also in a wooded area, and we're looking at quite a lot of biodiversity. So loads of depth to that. But if you're interested, look online at Passivhaus Plus magazine. I can put in a link into the chat later. The current online magazine, and will come out in paper soon as an in-depth article about this. Next. And really, your architecture can be what you want it to be. But one of the other key things is that the ventilation of the plant is considered very, very early on in the design to enable that to work effectively. Something that architects were trained not to think about that. And, that's essentially someone else's problem, but clearly that's not the case. Next. I'm going to hand back to you, Alejandro.
Yeah, thank you. And here I'm going to talk a little bit of those indoor air quality challenges and benefits that we can see in passive house construction. I'm going to go a little bit fast so I can give you as well some time for Q&A. I'm just conscious of time. So some of the challenges that we have, of course, is the building systems. We usually have a very good MVHR system, very good heating system, and so on. But once architects, housing associations, or whoever has the building handed to the occupants, they don't always engage with the system. They don't know how to do it, or maybe they don't care and just leave it in the standard settings as it came. And one of the problems is that if you don't engage with, in this case, for example, the MVHR system, the likelihood of air quality problems appearing at a later stage is quite high. One other important bit is looking at occupant behavior. So we have different bits of the occupant behavior here. So we have indoor sources, such as activities, cooking, and you can call it. Those will be producing some kind of pollution. And because the house is very well airtight, it's very airtight, and the ventilation system keeps ventilation not to a minimum, but just to a standard kind of thing. If we don't ventilate enough or open the windows, that pollution will stay inside of the house for longer term than what we would do in a house that is ventilated through natural ventilation, for example. The other thing here is there's a lot of perception that passive house homes are not designed to be open the windows. And this is one of the problems. Passive house homes actually sometimes rely in the occupants opening the windows at night, for example, during summer days for night ventilation. That reduces the risk of overheating, but as well, it gets a little bit more of ventilation, and it gives a chance for the house as well to have the dissipation of indoor air pollution. That could play as well both ways. If you open the windows and you live in a very transited road, well, you are going to let in outdoor pollution. But that is the other place on the MVHR system that we'll see later on as a part of the benefits. The other part, as we probably increase, have all the things in the house. Kirsty was mentioning that while there is not much interest in part of the passive house in looking at the materials that we're putting, not only as a building materials, but also as furnishing, those can produce certain level of off-gassing. So if we don't have enough conscient, or if we haven't designed the house with natural materials, for example, those off-gassing can lead to something quite extensive at a later stage, particularly once they are new, they have a couple of weeks, even months, where the off-gassing is quite high. And the pollution peaks as well, usually because if we don't open the windows in the passive house, we have a pollution peak, and then that pollution peak will take a lot of time to dissipate through the natural mechanical ventilation that we have. That could be that we also could just open the window to avoid that, but it usually doesn't happen, and that's something that we need to manage. And that's as well part of the engagement with the system. We could boost the MVHR system to avoid these kind of things. And finally, as well, we have indoor sources. So once we have started reducing other sources of pollution, cleaning and personal products, for example, can play a big role in terms of those indoor sources, for example, VOCs that can be lead to other kinds of problems. However, while there is some benefits on challenges on using those mechanical ventilations, there is as well some benefit. We don't know, maybe it's unintended or intended in the terms of how we do the filtration in the house. So we have here the MVHR system, and these are the filters that we have to get there in and out of the system. And this is what otherwise would be on your lungs. That is an MVHR filter that has been in the house for a while, so they tend to end very nasty in a way, and that's probably one of the key benefits in terms of air pollution that the Passivhaus is delivering. The other one is as well looking in terms of having those levels of comfort. As Kirsty was mentioning earlier on, people who move into Passivhauses, they have an expectation of comfort, but as well, they just discover that once they are living there, that expectation is actually exceeded in a way. The other bit here as well is just looking that we have probably a more controlled environment that we could as well play or do what we need to do if we know how to do it on the building systems. And the other part that we saw as well through those very quality detailing and as well how to reduce the thermal breaches, that's quite important to start looking at how we can reduce the risk of mold. But as well, the other part that will help us to reduce the mold is the constant ventilation that we'll have in the house. So compared to a normal house, a passive house will have constant ventilation most of the time. And could be that in a normal house, we don't have as much ventilation as some points we would like to have. And that can lead to these kind of problems. So this is just here looking at how probably an MBHR look in a utility system in a house. And finally, the point as well to make that is as well protection from whatever is outside. So towards avoiding that undesired infiltration, we can also protect that pollution from outside coming in. We have the MBHR system to help us with that. And that is something as well quite important and different in passive houses. So some of the key learnings that we have been getting through all here, I think that our tightness is part of the key, but as well how we detail the building. And I think that Kirsty have made a very good job in trying just to make that point. We have intentional ventilation on the ventilation systems and opening. Sorry, Kirsty, you were going to say something.
No, on you go. Thanks,
and as well, we have that perception of the occupants of the house that is increased in terms of not only air quality, but also on the indoor environment in general. And finally, we have some perceived comfort of indoor air quality versus what the national people would expect in terms of comfort. I don't know if you want to go into a little bit more of detail of any of these points, Kirsty, or we just open the Q&A session.
I think the other thing, yeah, so speaking to clients and having lived now one myself, the indoor air quality is one of the things that they're all absolutely delighted about and really couldn't have perceived that it was going to be as good as it is. Obviously, there's always room for improvement and learning. I think it really underlines the baseline that we have here of what we think is good in our homes and offices and so on is, of course, not great. And we do, of course, perceive that. So yeah, we get in a nice little anecdotes of clients slightly tongue-in-cheek saying they don't want to go and visit their friends because the houses are too heavy. Yeah. Anyway, yeah, let's open to questions, and if anyone's got anything they'd like to ask, we're delighted to discuss.
Great, thank you very much.